Okay, I'm going to show you an example of factoring using the difference of squares. If you recall, difference of squares simply says if we do have a polynomial where we're subtracting two perfect squares, we have a little shortcut here to factor. So to begin this problem, I'm just going to kind of quickly review the difference of squares, which says if you have two items that are both perfect squares being subtracted, we can easily factor these two items as base plus base times base, excuse me there, erase that, times base minus base. There we go. And just to show that this works, we could again FOIL to check. So if you take a times a, you'll get a squared. If you take a times negative b, you get a minus ab. B times a, you'll get plus ba, and minus b squared. If you take a look at this particular expression we ended up with here, negative AB and a positive BA, which is the same as AB, would cancel, leaving us in this particular case with A squared minus B squared. So this is a general idea we're going to use today in this example to factor 5x squared minus 80. Now, the issue that arises with this example is that 5x squared and 80 don't appear to be perfect squares. So the hint here is that we want to factor out the greatest common factor first. If you look at these two terms, the greatest common factor is 5. So we can rewrite this as 5 times x squared minus 16, like so. Now, again, you can double check. 5 times x squared is 5x squared, and a 5 times negative 16 is minus 80. Now, we have a unique situation where this value inside parentheses is a difference of squared. 16 could be written as 4 squared. So x squared minus 4 squared is a difference of squares. So to finish this problem, we need to factor completely. The 5 stays right there. And we're left with base plus base times base x minus base 4. So 5 times x plus 4 times x minus 4 is a complete factorization of 5x squared minus 80.